Coaching Classes YouTube channel. Today we discuss about the next point of the circle, touching circles. Now the definition of the touching circle is such as, now touching circles. Now suppose I have to draw one line and the points x, y, z are the collinear points on this line, and suppose x is the center of the circle and xy is the radius, then I have to draw one circle. Then again, if you take z as the center and yz as the radius, then this is the another circle. Now these two circles in the same plane and intersect in one and only one point y. Similarly, suppose you have to draw another circles taking x, y, z as the collinear points. Suppose I have to take here y point, here is x and here is z. Mean that x, y, x, z are collinear points. Mean that x, y, z are collinear points. And suppose you take as a center is x and xy is the radius, then the circle is, suppose that this is the circle which passing through the point y. And if you take yz as the radius and z is the center of circle, then this circle is again passing through this point y. In this case, y is the intersecting point of these two circles. Now, mean that in a plane, if the circle intersect one and only one point, then it is called as the touching circle. Now here is, these circles are externally touching circles and these circles are internally touching circles. Can you understand these two types of the circle? Internally touching circles and externally touching circles. Okay, we see the next theorem, very important theorem. The theorem is that if two circles are the touching circles, then the point of contact lies on the line passing through their centers. I repeat, if two circles touch each other, their point of contact lies on the line joining their centers. Now student, for this I have to draw two circles here. Now there are two types of the circles, internally touching and externally touching circles. First I have to draw the externally touching circles here. Suppose that the point A, B, C are the collinear point here. I have to draw one circles. This is the circle with center A, and suppose that this is the circle with center B. And the point of contact is C. Another one is this is one circle and this is internally touching circle. Suppose that this is the center of circle and this is the point of contact. Suppose that this is the C, this point is A and this is B. Then you have to draw the line. Two circles touch each other, their point of contact lies on the line joining their centers. म्हणजे point C हा A and B वरती असेल. I have to draw here tangent here. Suppose that this line here is the tangent to the circle and here is also a tangent line here. This is joint segment BC. Then by using this figure I have to write the given here. Given. Student, look here, if two circles touch each other, their point of contact lies on the line joining their centers. Now if two circles are touches, means that the point is C here. C is the point of contact of the two circles with centers A and B. This is our given. Here I have to write C is the point center, with centers A and B, with centers A and B. This is the given. Then to prove is that, mean that this point C lies on the line passing through these centers, mean that lies on the line AB. So I have to write here point C lies on the line AB. Point C lies on the line AB. Mean that the point ACB, mean that ACB are collinear points. For this, its proof is, now this is the line L and this is the common point as C. So here let line L be the common tangent passing through point C of the two touching circles. Mean that this line L is perpendicular to the segment AC, because tangent theorem, tangent is perpendicular to the radius. So I have to write here line L. Therefore line L perpendicular to the segment AC. Also for both this case, line L is perpendicular to the segment BC, because by using tangent theorem. Now then, mean that segment AC is also perpendicular to L and segment BC is also perpendicular to the line L. Therefore, segment AC is perpendicular to the line L and segment BC is also perpendicular to the line L. Mean that through point C, only one line is perpendicular. Therefore, through point C, only one line is perpendicular to line L can be drawn here. Line L can be drawn through point C. Only one line is perpendicular to the line L can be drawn here. Therefore, this point, mean that point CAB or ACB are collinear. If these 3 points are collinear, means that this point C lies on the segment AB. Therefore, the point C lies on line AB, and hence it is okay. Then we see the next points. Now we discuss about the practice set 3.2. The first question: two circles having radii 3.5 cm and 4.8 cm touch each other internally. Look here, internally. Find the distance between their centers. Student, if the circles are internally touching, then the distance between these two centers is equal to the difference between their radii. So, first I will take here, there are solution or answer of it is, let मानून घेऊया R1 and R2. Here R1 is equals to 3.5 centimeter and R2 is equals to 4.8 centimeter. This is our given. Then the two circles are touching circles. Two circles are touching each other internally. म्हणजे अंतर्भागामध्ये काय करतात ते टच करतात. Therefore by using the theorem, by using theorem of touching circles, the centers and point of contact are collinear. Point of contact are collinear. Therefore the distance between the centers of the circles touching internally is equal to the difference of their radii. So that distance between centers is equals to difference between their radii, means that R2 minus R1, because R2 is bigger. R2 is 4.8 and R1 is how much? 3.5. The subtraction is 8 minus 5 becomes how much? 3. 4 minus 3 becomes 1 centimeter. Means that the answer in full sentence, the distance between their centers, is 1.3 centimeter. Okay, we see the next question. The second question is, two circles having radii 5.5 centimeter and 4.2 centimeter touch each other externally. Now the first question is internally and second one is the externally. Little bit difference between this. Find the distance between their centers. Now student, in the internally touching we have to take its subtraction. For the externally touching circle you have to take the addition of that these two radii. Okay, here same question as the first one is, only difference here is external. Let the radii of two circles B, R1 and R2. Here the value of R1 is equals to 5.5 centimeter and value of R2 is 4.2 centimeter, which is given. Now these two circles are touching circles. The two circles are touching each other externally. Means that they are externally touching circles. Therefore, by using the theorem of touching circles, touching circles. The centers. The center and point of contact are collinear. Therefore, the distance between the centers and the distance between the centers of the circles touching externally is equal to sum of their radii. Because the two circles are external touching circles, so take its sum. Therefore, the distance between centers is equals to, here is sum, mean that R1 plus how much? R2. R1 is here 5.5 centimeter plus R2 is 4.2 centimeter. The addition becomes 5 plus 2 becomes 7, 4 plus 5 becomes 9 centimeter. Therefore, the answer in full sentence, the distance between their centers is 9.7 centimeter. Okay, we see the next question. Now student, question number 3 is for your homework. So simple one, you have to draw at home. Then question number 4. Very important question. In this figure, the circles with center P and Q touch each other at point R. A line passing through R meets the circle at A and B. This line meets the circle at A and B respectively. Prove that segment AP is parallel with segment PQ. This triangle APR is similar with triangle RQB, and find RQB if angle PAR is equals to 35 degree. Now student, here you write at home the given is that the circles with center P and Q touch each other at point R. A line passing through R meet the circles at point A and B respectively. Up to this is the given. Then this is the to prove. These 3 points are for to prove. Segment AP is parallel to segment PQ. Triangle APR is similar with triangle RQB, and find angle RQB if angle PAR is equals to 35. This is to prove. Then I will take its only proof. Student, here the point R is the point of contact of these two circles. Mean that these two circles are external touching circles, so that the point P, R, Q are collinear points. First I will take here point P, R, Q are collinear points by using theorem of touching circles. Now here in this triangle PAR, these segments are equal. In triangle PAR, segment AP is congruent with segment PR because radii of same circle. They are congruent. Means that by using isosceles triangle theorem, these two angles are also equal. So that therefore angle PAR is congruent with angle PRA. Suppose this is equation number first, and the reason is that by using isosceles triangle theorem. Or you have to also write here side angle opposite to congruent sides. Then in this triangle, in triangle QRB or QBR, in triangle QBR, this segment QB is also congruent with segment QR. Segment QB is also congruent with segment QR because radii of same circle. Again, by using isosceles triangle theorem, these angles mean that angle QBR means that this angle is congruent with angle QRB means that this angle QRB. Equation number second, again by using isosceles triangle theorem. Isosceles triangle theorem. Now student, next point is these two angles are congruent because they are vertically opposite angles. So I have to take here therefore angle PRA is congruent with angle QRB. Equation take as third. The reason is vertically opposite angles. Then look carefully. If this angle is congruent with this one, this is congruent with this one, these two is vertically opposite angle, mean that this and this angle is also congruent. So I have to write angle, therefore angle PAR is congruent with angle QBR. But when we observe these angles are alternate angles. So that by using alternate angle test, alternate angle test of parallel lines. These two line segments mean that AP and PQ are parallel to each other. So that our first is proof segment AP is parallel with segment BQ. So first is for this second, these two triangles we have to show here similar. So in triangle APR and another one is triangle RQB. Look at these two triangles APR and second one is RQB. The correspondence look carefully here. So I have to take here first angle is angle PAR is congruent with angle QRB. Look here. First one is PR is congruent with PRA. Then third one is, look here, third one is PRA is same, is congruent with QRB. Mean that these two is also congruent because first is congruent with second is congruent with third. Then first and third is also congruent. So I have to write the reason in that from equation first and third. Next the angle is angle PRA is congruent with angle QBR. Look at this one is second and third. QBR, here is QRB and QRBI is same. So that by using this PRA is also congruent with QBR. So I have to write the reason from second and third. Then observe carefully, there are two angles are congruent, so that these two triangles APR is similar with triangle RQB by AA similarity test. Hence our second is true. Now student, for finding the third value RQB, have cleaned this board. Now the third point is, here we have to find out the value of RQB. Look at this, RQB, this angle for this third. Measure of angle RQB is equals to question mark if angle PAR is equals to how much? 35 degree. Here is, look here, PAR is equals to 35 degree. This angle is congruent with this is also congruent with this, and this is also congruent with this. Mean that this and this angle is also 35 degree. So that I have to write first here. Now here angle PAR is congruent with angle QRB is congruent with angle QBR. Therefore, angle QRB is equals to angle QBR is equals to how much degree? 35 degree. Because PAR is 35 degree. So that in triangle QBR, sum of all angles of triangle is 180 degree. So that angle QRB plus angle QBR plus angle RQB is equals to 180 degree, because sum of all angles of triangle is 180 degree. So to this value is 35 degree. Then this is also 35 degree. Plus RQB is as it is equals to how much? 180 degree. This addition is 70. Transfer directly to this side, we get that angle RQB is equals to 180 minus how much? 70. Means that angle